Hey everyone, welcome back to CodeBrewWithAnirudh. Here we turn complex programming concepts into a freshly brewed cup of understanding. In our last video, we kicked things off by announcing this Java plus data structures in algorithms and object-oriented programming series. And we also talked about the complete roadmap that we will be following. Today we are diving straight into our first actual topic, that is Introduction to Programming. We will explore the different types of programming languages, difference between static and dynamic languages, stack versus heap memory, and many more concepts. And don't worry about jotting everything down because I will be providing you with the detailed notes so that you can focus on understanding rather than writing. So sit back, relax, and let's start building your programming foundation step by step. Alright, let's start with what is programming. Programming basically is the process of giving step-by-step instructions to our computer so that it can perform a specific task. Consider we have a task over here which needs to be performed. We will divide this task into n number of steps. Okay, we will divide this task into n number of steps. This n number of steps, we have to give it to a computer in the right order. Order is very much important. Okay, in the right order, we have to give it to a computer. Let's understand why this order is important through an analogy. Now, consider you have a robot that can make a cup of coffee for you. But this robot doesn't know anything unless and until you tell it exactly what to do and in the right order. Now, your instructions for the robot to make a cup of coffee for you would be: fill the kettle with 200 ml water, turn on the kettle and bring it to boil. Place filter and add coffee powder to it. Pour boiling water into the filter slowly. Pour coffee into the cup. Serve it hot. Now, if you skip any one step or mix up the order of these steps, the coffee won't turn right. For example, let's say we skip the very first step. Let's say we will not mention fill the kettle with 200 ml water. And we directly say, hey robot, turn on the kettle and boil the water. The robot will turn on the kettle. Okay, but there is no water in the kettle itself. There is no water to boil within the kettle. It will perform all of these tasks. At the end, what will we have? Nothing. There will be no coffee in the cup. Okay, programs also works in the exact same way. We have to give our computer clear and ordered instructions. It should be through a programming language. Okay, we have to give our computers ordered and cleared instructions, very, very clear instructions through a programming language. If the instructions are wrong, incomplete, or if they are not in order, then the computer will give wrong results for us. Now let's move on with the second topic and let's understand how computers are actually understanding the instructions. Before moving on with this topic, I want you to keep these 2 points in your mind. The very first point is computers don't understand human language. Computers don't understand human language. Human language in the sense, any language which we humans are using for communication purpose. It could be English. It could be Kannada, it could be Hindi, or any language on this world which we humans are using for communication purpose. Computers can't understand them. Now, the second point is computers can only understand one language. That language is known as binary language. Computers can only understand binary language. This binary language consists of zeros and ones. To be more precise, combinations of zeros and ones. Binary language will look something like this. Any combination of these zeros and ones. This is how binary language looks. And our computers can only understand them. And it is called binary language because bi means 2. Bi means 2. 2 represents these 2 numbers here. Therefore, it is called as binary language. Now, you might get confused You might get confused and you might ask me, hey Anirudh, if computers can't understand any human language, let's take English only as example. Let's take English as example. You might ask me, hey Anirudh, if computers can't understand English, how is my computer getting every single thing that I'm typing through my keyboard? Because you can see English alphabets over here. You can see English alphabets over here. How is my computer getting that? Well, whenever you press a key on your keyboard, there are a lot of things that is happening behind the scene. There are a lot of things that is happening behind the scene whenever you press a key on your keyboard. Let's understand and trace what happens right now. So this is the keyboard. This is the CPU. This keyboard is connected to the CPU through a wire. Cool. And within CPU, there are lots of components. There are lots and lots of components within the CPU. Let's list the key components of the CPU. Okay. What are the key components of CPU? Processor. Processor, which is the brain. Processor is the brain. Then we have RAM, random access memory. We have ROM, read-only memory. What else do we have? We have, okay, here is something very, very interesting. Here is something very, very interesting. And I want to talk about this. In most of the schools, they are teaching the basics of computer only wrong. Okay. Tell me if they have taught you this thing in your school. What I'm writing, tell me if they have taught you the same thing in the school. Hard drives, SSDs, pen drives, okay, floppy disks. All of these things are examples of ROM. Have they taught you the same thing in the school? Does this sound familiar to you? Have your teachers taught you this thing in your school? If they have taught you the same thing, then they have taught you wrong. Your teachers have taught you this one thing wrong. I will correct this today. In fact, even in my school, they have taught the same thing. You know what's more funnier? I have written the wrong thing. This is wrong. This thing is wrong. I have written the wrong thing in exam and they have given me marks for it. Why did they give marks? Because the same wrong thing is printed in the textbook as well. Wrong thing is printed in the textbook also. Okay? I have highlighted this because we will come back to it and we'll see why is this wrong. Okay, I will tell you why is this wrong. I will correct it. But before, let's complete the list. Let's complete the list of key components of the CPU. Okay, we have processor, we have RAM, we have ROM. Then we have hard drive, hard disk drive, and we have solid state drive. Then what do we have? We have GPU, graphics or graphical processing unit. Now, for all the people who are wondering, why have I written ROM, hard drive and SSD? HDD and SSD are basically examples of ROM. This is what you think. That's wrong. That is completely wrong. Okay, let's see why is this wrong and we will move on later. Cool? Okay. Let's see why is this wrong. Why is this common mistake made everywhere in most of the school? This is so much common. Okay. Let's see why is this wrong. Many textbooks and teachers group the SSD and HDD under ROM. They group the SSD and HDD under ROM. Why are they doing it? Why are they doing it? Just because ROM is a non-volatile memory. Non-volatile memory means it is a permanent memory. RAM is a permanent memory. So is HDD. HDD is also a permanent memory. So is SSD. SSD is also a permanent memory. Okay. What is permanent memory? Whenever you shut your system down, whatever the data is present inside this memory will not erase. But when it comes to RAM, when you are shutting your system down, everything inside the RAM will be erased. So this is called temporary memory. RAM is a temporary memory. ROM is a permanent memory. Read-only memory is a permanent memory. So is hard drive. So is SSD. So is pen drive. So is floppy disk. All of them are permanent memory. Okay. They have this one thing in common. Just because of that, they have grouped all of these things, hard drive, SSD, pen drive, floppy disk, under ROM. Just because of this one common thing. They all are permanent memory. But in reality, all of them are completely different. All of them are completely different. In reality, ROM and SSD or HDD are completely different types of storage. They have different purposes. What is that purpose? What is the difference? Let's see. Okay. You all know the full form of ROM. ROM is nothing but read-only memory. It is a permanent memory. Here is something which you didn't know. If they have taught you like this, so this is something which you didn't know. If they haven't taught you like this, then you might be knowing what I'm teaching you right now. If in your schools they have taught you exactly like this, then I'm 100% sure you won't be knowing this, what I'm teaching. Okay? So ROM is nothing but the full form of ROM is read-only memory. It is a permanent memory. Cool. Here is something new. ROM is built into the computer's motherboard. ROM is something which is built into the computer's motherboard. Consider this is your motherboard. This is your motherboard. ROM looks something like this. This is a ROM. Read-only memory. It is built into your computer's motherboard. Okay? This is built in. In fact, this is a chip. This is a chip that comes built in with your motherboard. And hard drive, SSD, floppy disk, pen drives are storage devices. These are storage devices. This is a chip. ROM is basically a chip. Okay? ROM is a chip which comes built in with your motherboard. These are not chips. These are storage devices. Cool. What is the next difference? Size. This is very, very small in size. This is very small. Not in terms of physical size. Even in terms of physical size, this is small. What I'm talking about, the MB/GB. You know how small the size of the ROM is? Very few megabytes. Very few megabytes. MB, that's it. What is the size of SSD and HDD when compared to ROM? These come in GB. These come in GB, gigabytes. Okay, now if you are wondering, if it has only few megabytes of storage, what does it store? If it has very few megabytes of storage and it comes built into my computer's motherboard, what does my ROM store? ROM basically stores the firmware or the BIOS. It stores the firmware or BIOS. Okay, what is this firmware or BIOS? These are basically the instructions to your computer which is needed, which is required for starting up. Okay, firmware or BIOS is stored within the ROM, which are nothing but the instructions for our computer to start up. You can't just store your movies, games, your photos, your personal documents inside ROM. You can't store it. In fact, you will never use your ROM. You will never use your ROM. You will never use this. Okay, you can't save your movies, games, your personal photos, your personal documents. Okay, nothing can be stored. It is not made for that. ROM is not made for that. ROM is made to store firmware or BIOS, which is nothing but instructions. And again, these instructions are stored in binary, zeros and ones. The instructions are stored in binary. Within the ROM, the instructions are stored in binary. This is a permanent memory. You can't rewrite this. You can't rewrite this. In fact, you will never use this. You will never use the ROM. Okay? You will never use the ROM. Now let's come back to hard drive and solid state drive. Hard drive and solid state drive are basically used for storing your operating system. Okay? Your operating system is stored inside this. If you have both SSD and HDD in your laptop or computer, operating system is stored in SSD. Why? Because SSDs are much faster when compared to HDD. SSDs are expensive as well. And SSDs don't have any moving parts. Okay? You drop your hard drive once, all of your data is gone. Okay? SSD, if you have both hard drive and SSD in your computer or a laptop, operating system is installed in your SSD itself. If you only have hard drive, then the operating system is installed in hard drive. Is stored in your hard drive. If you only have SSD, then obviously it will be stored in SSD. Okay? Let's discuss about what are the other things that are stored inside this. Operating system is one important thing. I wanted to discuss about this. Okay? Operating system is here. I wanted to discuss about this. But because I remembered about the ROM, I wanted to correct this thing. I went off the topic. Okay? HDD and SSDs are basically used for storing your operating system, your application, your movies, your photos. Okay, you can store all your digital life inside this. Your digital life can be stored inside this. Unlike ROM, you can rewrite this, you can read it, you can write it. Okay, if there is a document, you can modify it. And if there is a photo or something which you want to delete, you can delete it. This is flexible. This is flexible. The hard drive and SSDs are flexible. This is not flexible. ROM is not flexible. Okay. Now, just to conclude, so next time when someone says SSD or HDD is example of ROM or it is a ROM, you know the truth. You know the truth. Please correct them. ROM is a firmware storage. Okay. While SSD and HDD are our main storage drives. In fact, ROM is a chip. ROM is a chip. These are storage devices. All of these are storage devices. Cool. They have a different purpose, they have different design, and they have different job. Okay. Let's come back to the topic. Let me erase these things because these are not required. This is not part of our syllabus. Okay. This is the beauty about this series. Okay. Even in the very first chapter itself, I have included so many things. In the very first chapter, I have included so many things which was not a part of syllabus. This is how in detail I will be teaching you. Okay. Cool. If you think I'm wrong about the ROM, if you think I am wrong about the ROM, please Google it. Please Google it. You Google and search for yourself. You will get to know. Okay. Now, these are the key components of a CPU. Let's quickly discuss the responsibilities of each of these components. Okay. Processor is nothing but the brain of the computer. This is brain. This is the brain of the computer. It takes instructions from the programs and processes them. This takes instructions from the programs and it processes them. Faster the processor, faster the execution. Cool. Now, RAM, random access memory. This is basically short-term memory. It is a short-term memory. It stores data temporarily for quick access. Whenever CPU is performing some operations or it is processing something, RAM stores the temporary memory for the quick access. Okay, whenever you turn the PC off, RAM is cleared. All of the data present inside the RAM is gone. It is erased. Cool. Then ROM, read-only memory. Okay, as we just discussed about it, it's a permanent built-in memory. Okay, it is a built-in memory which stores the boot instructions. That is nothing but the BIOS or the firmware. Without ROM, your computer wouldn't even know how to turn on. Without ROM, your computer wouldn't even know how to turn on. That is the importance of ROM. I hope you understood the difference between ROM, HDD and SSD. Okay, and these devices as well, which I wrote over here. That is nothing but pen drives and floppy disk. SSD and HDD, as I said, it's a long-term storage. It stores everything. It could be your operating system to your personal documents. It could be your photos, videos. As I said earlier, your digital life can be stored inside this. And this is a permanent memory. Okay, this is also a permanent memory. If you shut your system down, all of your data will be there. It won't get erased. Okay, and SSDs are faster when compared to HDD, and SSDs don't have any moving parts. Hard drives have moving parts. Okay, and SSDs are much expensive as well. So the last thing is GPU. Nothing but the graphics processing unit. This is a special processor. Okay, it is a special processor. It is a special processor which is used to handle graphics. It is used to handling for graphics, visuals. It is very much essential for gaming. It is very much essential for video editing, and even for AI processing. The better graphics card you have, the better GPU you have, the AI processing is going to be very smooth. GPU is very much essential for AI processing. Okay, now let's come back to the topic. We were discussing how computers understand the instructions. I told this is a keyboard, and this keyboard is connected to this CPU via the wires, and the operating system is installed within the CPU. You can go and search in your system right now. There are lots and lots of drivers which is installed in your operating system. There are lots of drivers, and one of those drivers is keyboard driver. Keyboard or keyboards drivers. Okay, one of those drivers is keyboards driver. Now let me erase this thing as well. I want you to know your operating system is going to be part of hard drive or solid state drive. Okay, let's erase this thing as well. Now, let's consider I am clicking or I am typing on my keyboard. I have pressed the letter A. I have pressed the letter A. What do you think will happen? When I press the letter A, what do you think will happen? Will the keyboard directly send the letter A as a signal to the CPU? Will the keyboard send directly the letter A or the character A like this? Will it send the letter or the character directly to the operating system? Let me tell you, whenever you type something, operating system's keyboard driver is going to receive it directly from the keyboard. The keyboard will send the signal directly to the keyboard's driver, which is present inside the operating system. I am repeating it again. Whatever you type, what are the signal, we will figure out what signal is the keyboard sending. We will figure out about it. But keyboard is sending. What are the signal the keyboard is sending? Who is receiving it? The keyboard's driver, which is present inside the operating system. This is receiving the signal. So when I'm typing or when I'm clicking A, is my keyboard directly sending the letter A or the character A to the keyboard's driver? The answer is no. The answer is no. If it is not sending the letter or the character A directly, what is it sending then? What is it sending then? In all of our keyboards, there is something called as microcontroller. We have a microcontroller present inside our keyboard. Okay. And if you look carefully, the keys on the keyboard are basically placed in a grid manner. The keys on the keyboard are placed in a grid manner. What do I mean by grid? This is grid. You consider this as a keyboard and this is the grid. Grid is nothing but rows and columns. Okay. All the keys which are there on the keyboard are arranged or placed in this manner, in the grid manner. Let's assume that this is the letter A or the key A. In this grid, let's assume that this is key A. What is a grid? Grid is nothing but rows and columns. Rows and columns. So when I'm clicking A on my keyboard, when I'm typing, when I press A on my keyboard, what will happen is microcontroller, okay, listen to me carefully. This is very important. This is very much important. When I'm pressing A, the very first thing what happens is when you press a key, okay, when you press a key, an electrical circuit will be closed. When you press a key, an electrical circuit will be closed. The electrical circuit will be closed over here when you press a key. The microcontroller of the keyboard will detect it. The microcontroller of the keyboard will detect the key pressed. How will it detect? It will detect which row and which column. It will basically detect the intersection. This is a row and this is the column. It will detect this intersection. This column, this row. The keyboard's microcontroller will detect this intersection. Okay. The keyboard's microcontroller will detect the intersection, the row and column intersection. This intersection can also be called as position. So here I will call it as position of A. The intersection can also be called as position. This is nothing but the intersection itself. Okay, let me erase it. Okay, the keyboard's microcontroller will basically detect the intersection, which is nothing but the position. This position, the position of A, is mapped to something called as scan code. This is mapped to something called as scan code. Who is doing this? Again, the keyboard's microcontroller is doing this. The keyboard's microcontroller will map the position of A to something called as scan code. Okay, what is this scan code? What is this scan code? Scan code basically is a unique binary number. This is basically unique binary numbers. Binary numbers. Scan code is a unique binary number. This unique binary number represents which key on the grid was pressed. Okay. This scan code will represent which key on the grid was pressed. What was the step 1? Step 1 was you press the key. When you press the key, electrical circuit will be closed. Step 2 is microcontroller will detect the position or the intersection of the row and column of the grid. Step 3 is the intersection or the position of A is mapped to something called as scan code. Who is doing this? Microcontroller. The scan code is a unique binary number which represents the key which was pressed on the grid. I hope I am clear. Okay? This represents the key which was pressed on the grid. Now the next step is the keyboard's microcontroller will send the scan code. Okay, it is sending the scan code. The keyboard's microcontroller will send the scan code to the keyboard's driver. Okay, who is receiving the scan code? The keyboard's driver, which is present inside the operating system. Microcontroller will send the scan code. Okay. Now, what will happen next? Keyboard's driver will receive the scan code. The keyboard's driver will receive the scan code. This driver then applies the keyboard layout. It will first detect what layout first. Okay, this keyboard's driver will detect what layout of the keyboard are you using. The most common layout which we are using right now is QWERTY. This QWERTY. This is called QWERTY layout. Okay, there are many layouts of keyboard. There is something called as AZERTY layout of keyboard. There are many layouts of the keyboard. Okay, the keyboard's driver first will detect which layout of the keyboard is being used. Then this keyboard driver will apply that layout. By applying the layout, this keyboard driver will convert the scan code. Okay, it will convert the scan code into what? Into something called as virtual key code. Let me write it above here. Scan code is received here. It will convert it into virtual key code. Virtual key code. This is converted based on the layout which you are using. Okay. Now, this virtual key code which has been converted, the scan code has been converted to virtual key code. This virtual key code will be mapped to the actual character code. What is actual character code? Actual character code could be ASCII. Something called as ASCII. ASCII stands for American Standard Code for Information Exchange. American Standard Code for Information Exchange. Okay. Cool. So, I told you that the virtual key code will be mapped to actual character code. This will be mapped to actual character code. How does the actual character code look then? Let me show it to you. In ASCII, okay, the ASCII value of A is 65. The ASCII value of A is 65. The binary representation of this 65 is something like this. Okay. The binary representation of the 65 is something like this. This virtual key code is mapped into this. Is mapped to this ASCII code. Okay. Now, there is something called as operating system's event system. OS event system. Okay, this is called as OS event system. This OS event system will wrap this character into an input event and send it to the current active application in event queue. Okay, don't worry about it much. Okay, don't worry about this complex logic. Just understand this much. This is the ASCII value. Okay, ASCII value of A is 65. This is 65's binary representation. So the keyboard will convert the scan code into virtual key code based on the layout. Then consider you're using an application. You're using an application. It could be your Microsoft Word. It could be your Chrome. Okay. You're searching something on Google or Chrome. It could be your IDE. You are writing code on VS Code or IntelliJ. It could be your Notepad. It could be any applications. Any of these applications. Okay. Whenever you type A on your keyboard, all of this process happens. What will happen? I'll repeat it again. What will happen? If you didn't understand, listen to me clearly. When you press A on your keyboard, okay, your keyboard's microcontroller will detect the intersection. How is the intersection happening? When you press the key on your keyboard, a circuit will get closed. The keyboard's microcontroller will detect the intersection. What is this intersection? Intersection of the row and intersection of the column. Then this intersection or the position is mapped into something called a scan code. This scan code is a unique binary code. This scan code represents the key which was pressed on the grid. Okay. This scan code is transferred to your operating system's keyboard driver. The keyboard's driver will receive the scan code. Then the keyboard's driver will check for the layout of the keyboard. Based on the layout of the keyboard, it will convert the scan code into the virtual key code. Then this virtual key code is mapped into something called as actual character code or nothing but ASCII. All of these things happened, but my application has not yet received that character yet. After mapping, what does the operating system do? After mapping the character, operating system will send the binary number. Okay. Internally, it is sending the binary number itself. This binary number is sent to the application which you are using. Okay. This binary number is sent to the application which you are using. It could be any applications where you are typing something. Internally, it is sending this. This application is responsible for formatting this into the character and formatting into the font which you have chosen. But internally, what is it? It is all zeros and ones. Internally, it's all zeros and ones. At machine level, your CPU, your memory, your RAM, your ROM, your hard drives, your GPU, every single component, they can't deal with letters. They only deal with zeros and ones. I hope you have understood how these applications are receiving the character or the text which you have typed from the operating system. I hope you understood how this key, the key press which you have pressed, is being converted into binary number over here. Okay. If you have understood this much, okay, this is basically typing. These are not instructions. I am typing here. This is being converted. But what was the topic? The topic was, how does the computer understand the instructions? So we understood one thing over here. Computers can only understand zeros and ones. So our programs are basically high level language, which is nothing but, computers can't understand that. Java, Python, C, any language you choose, computers can't understand them. We need something to convert these programming languages into zeros and ones. So our programming languages, we need something to convert it into zeros and ones. So what is this something in between which is converting this program files or programming languages into zeros and ones. Those are called compilers. Okay. These compilers are responsible for converting this programming language into zeros and ones. In Java, there is compiler and interpreter both. We'll talk about this in detail in the next lecture. Okay, we have a detailed lecture. We will talk about this in detail. We'll talk about how Java achieves its platform independency. Okay, how does Java convert this? What is the responsibilities of JDK, JRE and JVM? We'll cover these things in detail, in very much detail. For now, just keep in your mind that programming languages are not directly understood by your computers. There is something which is required which converts your computer into zeros and ones, which converts your programming files or program languages into zeros and ones. I'm really sorry, I blabbered it. We need something that converts the programming language or the files which consist our program into zeros and ones. Those are compilers and interpreters. I hope I am clear. Let's move on with the next topic, that is different types of programming languages. Programming languages are categorized into 3 different types: procedural, functional, object-oriented languages. Let's have a look at them one by one. Procedural languages, as the name suggests, procedural. There is a procedure which is being followed. In simple words, we will be giving step-by-step instructions to our computer, step-by-step sequence of instructions to our computer to solve a problem. These type of programming languages are called procedural languages. Examples are C, Pascal, Java, etc. Many more. Okay. The second type is functional programming languages. In these type of programming languages, we write the program only in pure functions. And this language is preferred for use whenever or wherever a same operation needs to be performed multiple times. If there is a same operation which has to be performed multiple times, functional languages are preferred. Okay, examples are Haskell, Java and Python. I want you to keep one thing in mind. Okay, Java and Python, they only support functional style. They only support functional style. Java and Python are not purely functional languages. They are not purely functional. Okay, keep this in mind. Java, Python, they both are not purely functional, but they only support the idea of functional style. Cool. The last type of programming languages, object-oriented programming languages. In these type of programming languages, basically we organize the code into classes and objects. Okay. Objects will bundle data and behavior. Data is nothing but a field. Behavior is nothing but a method. Objects bundle the data and behavior together. Objects will bundle the data and behavior together. Okay. If you have a look at the examples could be Java, of course, Python, and C++, the C# as well. Ruby also supports object-oriented programming approach. Object-oriented programming has its own core principles. These are the 4 core principles. These principles are also called as 4 pillars of object-oriented programming. They are also called as 4 pillars of object-oriented programming. I'll write the pillar neatly. Word pillar. They are considered as 4 pillars of object-oriented programming language. We will not discuss about these things in detail right now. We will just have an overview of it. because there is a separate chapter which I have included for object-oriented programming where we will be covering all these things along with additional things as well in detail. Okay, for now we'll just have an overview. What is encapsulation? Encapsulation basically means hiding the details and you will be showing only the essential ones. Hiding the details and you will be showing only the essential ones. It could be, for example, your gallery. You will not hide all of your pictures. Okay, this is your gallery. You will not hide all of the pictures on your gallery. You will not hide all the pictures in your gallery. You will only hide the essential pictures which others don't have to see. You will only hide essential pictures which you don't want to show others. You will only hide those type of pictures and you will show the rest. This is called encapsulation. Encapsulation is nothing but hiding the essential details, okay, and showing only which is required. Showing only the details which is required. Cool. Second thing is inheritance. Simple example for inheritance is all of you. All of we humans. We humans, we have inherited the properties, the characters from our parents. Okay. We humans, we have inherited, okay, or we have got some properties and characters from our parents. Similarly, inheritance here is a subclass will be inheriting the data and behavior of the parent class. Cool. A subclass will be inheriting the data and behavior of the parent class. The third principle is polymorphism. Polymorphism means the behavior will be different for same actions. The behavior of a method will be different for same actions. Abstraction means hiding the complexity. Don't worry much about this right now. We will cover all these things in detail. We will cover all of these things in detail in the chapter Object-Oriented Programming. Cool. Let's move on with the next topic, that is static versus dynamic language. Static versus dynamic language. Okay. Here let's have a look at the difference between them. Java is statically typed language. Java falls under this category. If you ask me example for, the programming languages that fall under dynamic, you have Python, then we have JavaScript, Ruby. They all fall under dynamically typed programming languages. Then what is the difference between them? For static, we have Java, C, C++, Go, Rust, many more. So, in statically typed language, first we must declare the data type we must declare the data type of the variable before using it. We must declare data type of variable before using it. In dynamically typed language, we don't have to declare. Okay. Here, errors are caught at compile time. Errors are caught at compile time. Here, errors are caught at runtime. Cool. Statically typed languages are generally faster. Okay. These are generally slower. Okay. But they provide more flexibility for you. Dynamically typed languages will provide you more flexibility. Okay. This is about the static versus dynamically typed programming languages. Java falls under statically typed language, where we have to declare the data type of the variable before using it. Okay. what is data type, what is variable, all of these things we will cover in detail, don't worry. Okay, and these type of programming languages, they are much faster and errors are caught at compile time itself. Cool. The next topic is stack versus heap memory. Stack versus heap memory. This is very, very important. This is very important. Okay. There is at least like 50 to 60% chance your interviewer is going to ask about stack and heap memory in your technical interview. 50 to 60% chance. Okay. And I'm going to explain this in detail. Let's start with stack memory. Before moving with it, okay, I just want to give you an idea of what is stack. Okay, I just want to give you an idea of what is stack. Now imagine this is a memory. Okay, this is just like you can imagine this like a container or a tub or something like that, or a rectangular box. Okay, consider this as a rectangular box. In this box, you have placed your books. This is book 1. This is book 2. Okay. This is book 3. Now, the basic idea behind the stack is this follows last in, first out approach. Last in, first out. Last in means the last thing, okay, the last book which entered this memory or which entered this space will be the first one to get out of the space as well. For example, if I put book 4, one more book, this is the book which entered at the last in, book 4. Book 4 will be the one to get out of this container or space. Book 4 will be the one who will be getting out of this container or space. So without removing book 4, you will not be able to access book 3. And you can't randomly access, okay, I want book 1, I'll take out book 1 like this. No, that is not possible in stack. If you want to access book 1, then you have to remove book 4, book 3, book 2, book 1. Then you can access it. I hope you got an idea about it. Okay, this is exactly how the data structure stack also works. We will cover about stack in detail again. This is stack memory. That is stack data structure. How they both operate are same. How they are operating, it is same. Okay. But we will be covering it in detail, don't worry. Now you have a basic idea of what is stack. Okay. Let's understand how stack memory works. So the very first point I want to tell is all primitive data types are directly stored in stack. All primitive data types are directly stored in stack. What do I mean by primitive data types here? Don't worry about this. Okay, don't worry about this. We will cover this. We have a separate chapter, data types and wrapper classes. We will cover about it in detail. We will cover what is primitive data types, what is non-primitive data type, what are wrapper classes. Wrapper classes is something which your colleges don't teach you. Wrapper classes. This is very much essential for your project development. Okay, I will be teaching you this in the very next video itself. In the next video itself, we will learn about primitive data types and non-primitive data types in detail. But for now, just keep in your mind that all primitive data types are directly stored in stack. What do I mean by that? I'll show it to you. So consider this is a stack. This is a stack. Int is one primitive data type. Int is one of the primitive data types. Okay. Int is one of the primitive data types. A is a variable. 10 is the value. Just to make you people understand. Okay. Int is a data type. A is a variable. 10 is the value. This is variable. This is called as object or value. This is data type. Now in stack, all of these three things are directly stored here for primitive data types. For primitive data types, all of these three things are directly stored here in stack. Cool. Float is one of those another primitive data types. Character is another primitive data type. Okay. The data type, variable and its value, all of these three things are directly being stored in the stack. All the three things. Okay. This is what I meant by all primitive data types are directly stored in stack. Okay. Next point. Let me move this to the left and so that we can write some points. Okay. Next point. The second point is memory allocation happens when the method is called. Memory allocation happens when method is called. And memory is freed. Okay, the memory is freed as soon as the method ends. As soon as method ends. Okay, and stack memories are very fast. Stack memory is very fast. Cool. Remember these points, especially this one. All primitive data types are directly stored in stack. All primitive data types are directly stored in stack. It are stored like this. Like this. The data type, variable and its value is directly stored in stack. Cool. The second point is the memory allocation happens when a method is called. Okay. And the memory is freed as soon as the method ends. Stack is very fast when compared to heap memory. One more thing I want to tell you is stack memory is used to store. Okay, they are used to store. Let me write it down actually. They are used to store method calls. They are used to store local variables. Okay. And even references as well. Okay. Stack memory is used to store all these things. Now, the major difference between stack memory and heap memory is, I will show it to you now. So let's have a look at heap memory now. I'll draw a line here so that we can partition it. Okay, we are talking about heap memory now. So the one point which I want you to remember is all non-primitive data types are stored in heap memory. Notice the difference here. Here I am saying all primitive data types. Okay, all primitive data types are directly stored. Here I'm not using the word directly. All primitive data types are directly stored here. Means all three values are directly stored here. But I'm not using the word directly here. I'm just saying all non-primitive data types are stored in heap. If they are not being directly stored, how are they being stored then? I will show it to you. So for storing something in heap memory, stack is also required. For storing something in heap memory, stack is also required. So this is stack memory. Heap memory will look something like this. Okay, this looks something like heap memory. Okay. Now, string is one data type that is non-primitive. String name is equals to Anirudh. String name is equals to Anirudh. If this was primitive, if this thing was primitive, what would happen? String name is equals to Anirudh. All of these things will be directly stored in stack memory. That's what we are doing here. All of these things, character, C is equals to A. Character is a primitive data type. Float is a primitive data type. Integer is a primitive data type. String is a non-primitive data type. String is a non-primitive data type. Cool. So therefore, how is this string stored in the memory then? String is stored in heap memory. All non-primitive data types are stored in heap memory. How is it stored? Let's have a look at it. String name is equals to string name equals to the data type and the variable name or the reference variable is being stored in the stack memory. But the actual object or the value which is over here is being stored in heap memory. The actual value or the object is being stored in heap memory. Cool. This memory where it is stored, the value is stored, it will be having an address. The memory will be having an address. For now, let's consider this as ABC XYZ. ABC XYZ is the address. In the stack memory, the string name, what is stored here? What is being stored here? The address of the memory, the address of heap memory, where the value or the object is being stored. Or in other words, okay, this will be pointing towards the memory. String name will be pointing towards the memory. Okay, if I have to say it directly, this address, ABCXYZ. Okay, ABCXYZ. This address is directly stored here. This address is stored here, not the value. Okay. This is how heap memory is stored. This is how heap memory works. All non-primitive data types. We will talk about it again. Don't worry what is non-primitive data type, what is primitive data type. We will cover this in detail in the next lecture. In the very next lecture itself, we will cover about this in detail. Cool. Now, I told you that in stack memory, the memory allocation happens when the method is called. In stack memory, memory allocation happens when the method is called. But in heap memory allocation will happen. I'll erase this one so that I could write some points. Okay, in heap memory, memory allocation happens dynamically. Okay. Memory allocation happens dynamically. Dynamically means during the execution of the program. During the execution of the program, memory allocation happens dynamically. What was the next point here? Okay, memory is freed as soon as the method ends. Memory is freed as soon as the method ends. In heap memory, the allocated memory will still exist. Allocated memory will exist until the garbage collector frees it. Okay, garbage collector frees it. What is garbage collector? We'll talk about this in detail in the next video. Garbage collector is basically responsible for your memory management, and garbage collector is present in JVM. It is present in JVM. And if you watch the previous video, we will talk about JVM in the next chapter, which is nothing but the next video. Okay, so don't worry about it. Just for now, just understand that garbage collector is used for memory management. It is present inside JVM. JVM is nothing but Java Virtual Machine. What is it? Don't worry, we'll cover about it in detail. We'll talk about this in detail in the next video. The next thing I want to talk about is why start with Java. One of the biggest reasons I recommend Java to beginners is because it is beginner friendly. Java is beginner friendly. You might ask me, hey Anirudh, how is Java beginner friendly? We have to write 3 to 4 lines of code with so many words just to print something on the console. And yes, you are right. Compared to languages like Python, Java does make you write a bit more code. But here is the thing. This extra code isn't just a fluff. The extra code you are writing isn't just a fluff. It is teaching you the fundamentals that are actually crucial in programming. You'll learn how classes work, you'll understand the concepts of methods, you will get familiar with the structure of a real-world program. Let's say in future you will shift to some other language. So when you move to other languages later, you will already be having understanding of how the code is organized. You will be having an understanding of it rather than just, typing quick commands without knowing what's happening under the hood. Cool. The second point is strong foundation for object-oriented programming. Java is fully object-oriented, which means that from day one, you'll be thinking in terms of objects, classes, and methods. These concepts are used in the modern programming languages. These are the concepts that are most used in the modern programming languages. The third point is platform independence. Java follows something called as VORA. The full form is write once, run anywhere. Means write once. Let's say I wrote a code in my Windows machine. I will be able to run the same code in macOS, in Linux. You name the operating system. That's a huge advantage. That's a huge advantage when you are learning and testing your projects. We will talk about platform independence in detail. We will see how Java achieves platform independence. In the very next video itself, we will see. We'll talk about the platform independence of Java in detail. The fourth point is industry demand. Java is one of the most in-demand programming languages on this world. Java is used for developing Android applications, web applications, enterprise softwares, game development. Java opens a lot of career opportunities. Java does open a lot of career opportunities. Cool. These were some of the points. Why you should start Java. Why you should start with Java. So yes, while Java might feel a little wordy in the beginning, it's actually giving you a rock solid foundation. Okay, it's giving you a very, very rock solid foundation that will make you a better programmer in any language which you will be learning next in future. Cool. This is going to be the last topic which we are discussing on this video. This is going to be the very last topic. But this topic has a lot of subtopics. Okay. This topic has a lot of subtopics. Bear with me for a few minutes. These are very important for building a base, for building the foundation so that you can understand Java much better. We have talked about variables, we have talked about data types, but we don't know what are variables and what are data types yet. Okay, we are going to talk about this right now. The key programming concepts. The very first thing is variables. Variables are nothing but the containers that are used to store and access the data. Variables are nothing but they are containers that are used to store and access the data. Cool. Think variables as a label jar. Okay, they are a label jar in your kitchen. For example, in your kitchen, you have a label jar as sugar, salt, okay, coffee powder. These are the jars. These three are the jars. You have sugar, you have salt, you have coffee. Now, these labels basically define what is supposed to be put, what can be put in this container. In sugar container, will you put salt? No. In the coffee container, will you put sugar? No. Okay. So, these labels are basically data types. We'll talk about it. But these containers are basically variables. Variables are nothing but containers which are used to store and access the data. I hope I'm clear. For example, let's take an example. Okay. Let's say int age is equals to 25. Age is the variable here, which is storing the value 25. Okay. In kitchen analogy, age is basically the jar. Age is basically the jar which is storing the number 25. Age is basically the jar which is storing the number 25. So we talked about this. This is variable. This is a value. This value is stored in this variable. What is this then? This int. Int is basically the data type. This is the data type. So let's talk about data type now. So data types basically define what can be stored inside the variable. For example, this age variable is of type int. This age variable is of type int. I can't store a floating value or a string or a character value inside this variable. Why? Because this data type is basically defining what can be stored inside this variable. If I declare a variable as int, only integer types of data can be stored inside this. Okay. Cool. There are a lot of data types. Okay. Just to give you a brief introduction, int is one data type which stores whole numbers. It stores whole numbers. It could be or minus 99. All negative positive numbers including 0. 1, 9, 100, 1000, any number. Whole numbers. We have data type something called as float and double. These are used for storing decimal numbers. Decimal numbers mean something like this: 3.14, 9.6, something like that. We have one more data type called as character. Character is nothing but a single letter. You can store a single character or number, something like this: character A or small letter B. Even number can be stored as a character. Even special symbols like asterisk or your dollar symbol can be stored as a character. This is not star symbol. This is called asterisk. Good. So we have one more data type called string, which can store group of characters. Okay, it can store a word or a sentence. It can basically store a word or a sentence. It could be something like just a word, hello. Okay. Notice characters are, defined within the single quotes. A is written within single quotes. String is written within double quotes. Okay. You can even write a sentence like, how are you? Question mark is basically a special character. Even that can be mentioned within the string. We have one more data type called as Boolean. Boolean means true or false. It only has true or false. Okay, we'll talk about this again in detail. The next thing which I want to talk about it, I hope you understood what are data types, what is variable. Okay. The next thing which I want to talk about is operators. Let's talk about operators. Operators. So let me come back to data types again. Data types also determine what are the operations that can be performed on the specific variable or the data. What are the operations that can be performed on the specific variable or the data? What do I mean by operations then? Let's take the kitchen analogy again. We have 3 jars. This is sugar. This is salt. This is coffee. Using these 3 things, what are the operations that can be performed? Using coffee powder, I can make a cup of coffee. I can even use sugar as well. Using sugar and coffee, I can make a cup of coffee. Cool. But can I make pasta using coffee? No. Can I make pizza using coffee? No. As far as I know, you can't make pasta and pizza out of coffee. It's, sounds very weird combination to do. So let's assume we can't do it. We can't perform the operation or, cook pasta or bake pizza. You can't do it. But you can make a cup of coffee. Can you make pasta or pizza using sugar and salt? I'm not saying just sugar and salt. We of course need other ingredients as well. But salt is used in making pasta. Salt is used in making of pizza. Sugar is also used, I guess. Sugar is also used. Cool. This basically cooking or baking, what we are doing on these jars are called operations. Similarly, operators are used to perform some operations on the variables or the data. What are those operations? Operators are basically categorized. Okay, they are categorized into several types. The first one is arithmetic operators. Arithmetic operators. Using arithmetic operators, you can perform addition, subtraction, multiplication, division. There is one more thing. There is one more thing called as modulo operator. This is called modulus operation. Cool. This is not your percentage symbol. Okay, this is not your percentage symbol. This is modulo operator. And in programming, we don't write multiplication like this. We don't write x. In programming, we write the symbol asterisk, the star symbol. We don't call it star symbol, but for multiplication, we use this. Cool. So these both of the things are used for division. The forward slash and the modulo operator, both of them are used for division. What is the difference between them? Let's understand. Consider we are dividing 7 by 2. So 2 3s is 6. We have one remainder. Using the forward slash operator, if we use this operator, if I write something in my program like this, 2 by or 7 by 2. If I write something like this, 7 by 2, my answer will be quotient. So forward slash will give me the answer quotient, which is 3. But modulo operator, okay, if I write something like this, 7 mod 2, will give me the result of remainder. To get a remainder, we will use modulo operator. To get the quotient as an answer, we use forward slash. Cool. These are arithmetic operators. The second type of operators are comparison operators. These are also called as relational operators. Comparison operators are basically used to compare two values. These are used to compare two values. And one more thing is, these operators return Boolean result. First, let's see what are the operators. We have something called equals to, which is used to compare two numbers if it is equal to the other number. How is it used? Is 9 equals to 9? This will return true. Is 9 equals to 10? This will return false. Cool. Equal to operators. Double equals is used for comparison. Single equals is used for assignment. If you see here, we are using single equals. This is assignment. We will talk about this also. We have assignment operators as well. But keep it in mind, single equals is used for assignment, assigning a value to a variable. But double equals is used for comparison of two variables. We have something called as not equal to. Is 5 not equal to 6? This will return true. We have something called as greater than, we have less than, we have greater than or equal to, we have less than or equal to. I hope you got the idea of all these operators. Then we have logical operators. Logical operators. Logical operators are basically, used to combine or modify the Boolean expressions. You already have a Boolean expression. Okay. So using logical operators, you can modify them or combine them. What are the operators we have? We have logical AND, which uses two AND symbols. We have logical OR, which uses the pipe symbol. These two straight lines is called pipe symbol or pipe operator. We have logical NOT. We have logical NOT. So how does this work? We have something called as truth table. For the people who have, studied digital circuit, if you are from a computer science background, and for the people who are coming from electrical or electronics background, you might be knowing this. AND gate, OR gate, NOT gate. You have studied these things in your, in your engineering academics. So for the people who don't have idea about this is how it works. Let's say X, here let's take Y, and here let's say X and Y. This is logical and here let's take X or Y. This is pipe operator. This, and let's say not X. Let's even take not Y as well. So the truth table will look something like this. The condition of the truth table is based on the condition of these two variables, X and Y. X and Y are variables. So let's say this is true, true, false, false, true, false, true, false. So the logical AND operator, okay, the rule of the logical AND operator says that the result of the two Boolean values will be true, okay, only if both the variables are having true as their values. If true and true is there, result will be true. If any one of them is false, then it's all false. Got it? Both of them have to be true, then only the result will be true. If any one of them is false, then everything will be false. OR gate says if any one of them is true, then the result is true. True and true, one of them is true, therefore the result is true. True, false, one of them is true, the result is true. False, true, this is true, therefore this is also true. False and false, not even a single variable is, true. Therefore the result over here is false. What is this NOT operator? Not X. Not X is basically the reverse of this value. If it is true, then it will return false. If it is false, then it will return true. Same to Y also. If it is true, it will return false. If it is false, it will return true. I hope you got this. This is very simple. I hope you got the idea of this. Okay? These are logical operators. Next, I told you we will talk about assignment operators. Let's talk about assignment operators. Assignment operators. Assignment operators are basically used to assign values to variables. Assign values to variables. What are the operators we have? We have already looked at one, that is single equals. This is also called as simple assignment operator. This is also called as simple assignment operator. There are some other assignment operators. These are called compound assignment operators. They include plus equals, minus equals, asterisk equals or nothing but multiply equals, / equals, modulo equals. How are these working? We will see when, in practically when we are working on programs. We will have a look at them. Next, we have unary operators. Unary operators. Unary operators are the one who operate on a single operand. They don't need two values. They don't need two operands. For example, 2 plus 2 equals to 4. Plus needs two operands. Unary operator doesn't need two operands. It works on single operand. We have increment operator. We have decrement operator. We have unary plus. We also have unary minus. This is different from the arithmetic operators. Then we also have logical NOT. Logical NOT, we have already covered it in logical operators here. This is also a unary operator, because you see here x and y. AND operator is taking two operands x and y. OR operator is taking two operands x and y. But NOT operator is taking only one operand, that is x. So logical NOT is also an unary operator. The next type of operator is ternary operator. Ternary operator. We will talk about ternary operator again in our upcoming chapter, that is conditional loops and control statement. Ternary operator, this is the only operator, okay, that takes three operands. It takes three operands and it is a shorthand for if-else statement. We will talk about what is if-else statement and the chapter conditional loops and control statement. Okay, for now, just note down the syntax. The syntax for this. You will write your condition first. Then you will write a question mark. If this condition is true, whatever the expression has to be executed, then that one you will write here. Expression. If true, then you will write a colon. If this condition, whatever you are specifying, is true, then this will be executed, the first line, which is before the colon. If this condition is false, then whatever the code you write after the colon will be executed. So I'll write it as expression. If false. Just to, give you a better understanding, I'll take an example. Okay. So let's say the condition first. Condition is 2 greater than 1. Okay. Is 2 greater than 1. The condition is 2 greater than 1? Question mark. If 2 is greater than 1, then I will, for now, don't focus on this. In Java, we use system dot ss capital out dot println to print something on the console. Don't focus on this. Don't focus on system.out.println. Just keep it in your mind that we are using system.out.println to print something on the console. What is this system? What is this out? What is this println? I will explain it to you in detail in the next video. Very next video, we will talk about this in detail. We will say greater. Okay. This is colon. Else we will say system.out.println smaller. Colon has to become here. Semicolon, sorry. At the end. I can move this thing to the left and mention the semicolon as well so that you don't get confused. How does this thing work? So this is a condition. Is 2 greater than 1? I told you comparison operators basically return the Boolean values. Greater than is one of the comparison operators. Greater than is one of the comparison operators. Let me take greater than equal to. You will get better understanding of this operators. Is 2 greater than or equal to 1? 2 is greater than 1. True. True. It is this. If this condition is true, this will be executed. It will print greater on console. This won't get executed, this part. This part won't get executed. Because the condition is true, this will get executed. Let's modify the statement now. Is 2 greater than or equal to 5? The condition is false. If the condition is false, this true statement, the true expression will not get executed. This will get executed. I hope you just have an idea about what is ternary operator and why is it used. Don't worry if you didn't get how is this working. We will talk about this in detail in the upcoming chapter. The last type of operator which I want to talk about is bitwise operators. Bitwise operators. Bitwise operators are basically used to perform individual bits, operations on individual bits of an integer. Okay, we will talk about this in detail. Again, I have a separate chapter included for this. We have bitwise AND. Notice the difference. This is single AND. In logical operators, in logical AND, we had double AND symbol. This symbol was double in logical AND. This is bitwise AND. Therefore, only one single AND is there. Bitwise OR is single straight line. Bitwise XOR is there, which is cap symbol. Bitwise NOT is something like this. This is basically present, okay, to the very left below your escape key. We even have, okay, left shift operator, something like this. We have right shift operator. We have unsigned right shift operator. 3 greater than symbols. We'll talk about this in detail in the upcoming chapters. Just keep it in your mind that these are the operators. Okay. The next thing I want to talk about is control flow. I'll talk about control flow. Control flow. So, the first thing I want to talk about is conditional statements in this. This is basically an introduction for third chapter. Conditionals, loops, and control statements. This is just an overview of the chapter. Conditional statements. What is a conditional statement? Conditional statement is the one which will decide what to do based on the given condition. Have we already come across any conditional statement? Yes. Ternary operator. 2 is 2 greater than or equal to 5. Isn't this the condition? Isn't 2 greater than or equal to 5? Isn't this the condition? In fact, in syntax only we have written here. This is the syntax. Condition. Based on this condition, it will decide either this should be executed or this should be executed. Similarly, we have if loop, if statement, if else statement, else if ladder statement. We have switch statement. Okay, all of these statements basically help us to, make decisions in our program. Our program will gain the power of making decisions based on the condition. The second thing I want to talk about is loops. Loops are nothing but you want to repeat something multiple times. We'll talk about this in detail. Loops are used to repeat something multiple times. Okay. The last thing, the very last subtopic is functions. Functions. Functions are nothing but a few lines of code which is bundled. Okay. I'll talk about functions. The next thing I want to talk about is functions. Okay. Functions can be used again and again without rewriting the same block of code. Functions are nothing but a block of code. Functions are nothing but a block of code which can be used again and again, repeatedly, without, rewriting the same block of code. Now you might get confused. I told you loops are used to repeat something multiple times. And I'm saying the same thing for functions as well. So functions can be used again and again repeatedly without rewriting the same block of code. What is the difference between them? When to use functions, when to use loop? We will talk about it in the upcoming chapter. Don't worry about it right now. Don't worry about it right now. Cool. This is it for this video. I know it has been a very, very long video and you have taken a lot of things inside your brain. But don't worry, don't get overwhelmed because of these things. These are just basics. You don't have to understand these concepts in depth. In fact, there are some topics, for example, this operators, variables, and everything. I just wanted to give you an overview of it so that you don't feel difficult from the upcoming classes. Cool. If you didn't understand some of these things, don't worry, we will cover in detail in the upcoming chapters. Okay? We will cover all of the things in detail in the upcoming chapters. Cool. See you in the next video. Like, share, and subscribe if you like the video. Share it with your friends who are starting learning Java or who are interested in learning Java. Cool. See you all in the next video. Thank you so much for watching. Bye-bye.